Welcome to the Winedown, an afternoon podcast where two techie blokes sit down over a bowl of wine and chat about what's happening in the world of tech. Enjoy while Scott and Nick open up about their week in technology.
Well, hello once again and welcome to the Winedown. I'm here with
Scott.
Hello, Scott. How are you?
Hello, Nick. How are you?
I'm very well indeed. Well, let's start as we normally do. Where are we? What are we drinking?
We are in the DY Hotel today because we know on this particular day it's actually fairly quiet here. We can get a good session going. But we also know that in our wonderful investment of technology, as one should do in any business, we've actually got really good microphones that tend to make the background noise disappear.
They make it go away. It's absolutely brilliant. And not only that, as what Scott's not telling you, is it's $15 lunch as well, and that's probably really why we're here.
Yes, which we actually found out when we got here. But anyway,
it wasn't great advertising, but we are here and we've done
it was a great
that.
result.
So let's talk about the wine today. Here it is. It's red, it's liquid, and it's kind of yummy.
Yes, hey, look, something a bit different and a bit special again. I'm generally one to avoid bottles with fancy labels and various things because, if the best-selling thing about the bottle is the colour of the picture on the label, you're probably not in for a great wine. And some of the bottles are better ones that sort of describe the wine, where it's from, how it was produced, and the family generations and so forth. But every now and then you come across the odd sort of thing, and this was a bit of a gamble because I wasn't familiar with this. It's a bottle called from Brave Souls.
Brave Souls, is that us?
And I thought, well, look, how bad could it be? But it's a 2018 GSM, so it's a Grenache Shiraz, and I always mispronounce this, but Mourvedre.
I'll let you keep going with that. I can't see it from him, too blind.
That's all right. I can mispronounce it in many ways. But it is Barossa. It's a 2018 wine. And look, it's very drinkable.
Cool. Excellent. So that's the wine. That's where we are. Let's talk about the technology subject. What are we talking today?
So look, with where we are, I thought we'd actually cover a little bit on Wi-Fi, not just today, but for the next few podcasts as well. A bit of an update on Wi-Fi, where it is, what's the current state of Wi-Fi, what are the technologies you should be deploying, because you know what, Wi-Fi is getting pretty important.
It is, and it's a great Australian invention as well, which is what makes it really cool.
Right. CSIRO.
Invented by the CSIRO. In
Yes.
fact, they did an exhibition, and I saw the original testing kit where they actually made Wi-Fi work, which is also quite impressive. But it doesn't really resemble that anymore. It's way different to how it was.
You don't need to carry it around in a box and
with an oscilloscope. No, you don't. So we're going to do some physics, I think, to start with, aren't we?
Okay, look, foundation, and we'll keep this very simple, but it's good to have the background just to understand how does this all come together.
Sure. Okay, so he's just going to throw it straight over to me, so I have to come back with it. So we're going to talk about Wi-Fi, we're going to start with physics, and we're going to start with something called frequency.
Yes.
And frequency is the number of times something happens in a defined time period, normally a second, right?
Yes.
And we've got a measurement for that, as we've got a measurement for everything in physics. And the measurement we use is hertz.
Exactly.
So that sounds sore. Why is it called hertz?
Okay. So look, let's probably say what is a hertz?
Mm-hmm.
A hertz is the number of times that a wave can cycle in a second. So when we talk about 1 hertz, it means that in a second, a transmission can change once per second. But we don't have a lot of things measured in hertz today. What we have measured in megahertz, gigahertz, and so forth.
But I would say sound goes from 20 hertz to 20 kilohertz.
That is correct.
So you're listening to waveforms at the moment. But as we get higher and higher frequencies, that's how we can start transmitting data through the air using electromagnetic radiation, which is how we do radio and how Wi-Fi works. And Wi-Fi we tend to measure in gigahertz, right? That's kind of where it lives.
Currently, yes, in gigahertz.
So a giga is 1,000 mega, and a mega is 1,000 watts, right? So
yes. A mega is a million. Otherwise, it's kilo.
Kilo, mega, giga. Right. So if I've got 1 hertz, which is 1 cycle per second, then a kilohertz, which sounds like that horrible tone you sometimes hear in audio.
Yes,
and that's 1 kilohertz. And then you've got a megahertz, which is now bursting into radio, and a gigahertz, which is really radio. But as you get higher in frequency, you can transmit more data across it, but you get more line of sight, don't you? Things get in the way.
You get issues.
So slower radio waves will travel for thousands of miles and bounce off the atmosphere.
Yes.
The higher the frequency you get, the more a window will block it or a wall will block it.
And this is also why the initial, some of the networks that do IoT, when you've actually got IoT devices with very low frequency devices in them, saying we can travel up to 30 or 40 kilometres, not a problem, and send a little bit of data.
Yeah, but not very much, right?
No, but if you think you've got a temperature sensor out on a farm somewhere, it just needs to say, look, it's 10 degrees or it's 12 degrees.
Yeah, you don't care really, do you?
No.
You don't.
Interestingly, though,
Yeah.
so what Wi-Fi we tend to measure either in something like 2.4 gigahertz, which is a fairly common sort of range, or 5 gigahertz.
Yep.
Now, as part of that 2.4 gigahertz, there is a state transition of 2.4 billion times a second, and 5 gigahertz is a state transition of 5 billion times a second, and that's how we can actually send data, knowing
Right.
that every one of those little bits can gradually add up to a bit of data.
Yep. Cool.
Something
Excellent.
else. Where did hertz come from? How did we name hertz?
It's got to be from a guy, right?
There was a guy. There was, and this is an interesting story in itself. And I've actually come to some thoughts about this, but I haven't been able to verify them. So there was a guy called Heinrich Hertz. He was a German physicist, and he died in the late 1890s thereabouts. But he was the one that actually worked out that this electromagnetic signaling and radiation, we can actually measure it. We can do things with it. We can create transmitters and that sort of thing. So that was interesting.
Excellent.
The other interesting bit about this. He died when he was 36.
Oh my goodness, that's not very old.
Well, so now you think about, here's the guy that discovered electromagnetic radiation and is going and testing and doing it. He died when he was 36. His wife had no more children after that, and his 2 daughters never produced children.
So that was it. The whole Hertz name was
it
gone.
ended.
Wow.
But I'm wondering now, like, what did he do to discover electromagnetic radiation that made him either die early or made
good
his
point.
children unable to...
Oh dear.
I don't know if there's a connection. It's just the first thought that came into my mind. It's like the bomb
Yes.
guy
Yes.
who managed to radiate himself.
Or Madame Curie, who managed
Yes.
to radiate herself. Yes. So
Anyway,
moving
moving right along.
Interesting. So when we talk about ranges of frequencies, we call them spectrums.
We do.
Right? And Wi-Fi has a couple of spectrums. And you mentioned 2.4 gigahertz, but there's another one, isn't there?
It's the ZX81.
I programmed one of those, but I don't think we need to go there. No,
Okay.
ZX81 wasn't a spectrum, by the way. And the reason the spectrum was called the spectrum was the ZX81 was black and white, and the spectrum was in colour.
Oh, there we go.
But-
I stand corrected
but we
on
don't-
the ancient technology.
We don't need to go into ancient technology here.
Okay. Spectrums, let's have a look. So there are 2 general spectrums used for Wi-Fi. One, we have the 2.4 gigahertz, and we have the 5 sort of range. Now, the 2.4 are very commonly used, and not just by Wi-Fi, but all sorts of things. Microwaves out of a microwave oven are at 2.4 gigahertz. Bluetooth fits into that spectrum. There's a whole variety of things that fit in
So
there.
is that when I'm playing Tetris on the toilet, and the kids turn on the microwave, which is in the room next to me? I can't do any online stuff.
That's exactly why your game fails. Yes, I'm sure that's exactly what it is. It wouldn't have anything to do with the fact that a bathroom would have harder tiled walls and metal pipes or...
Yeah, all right.
Okay.
So our 2 spectrums, 2.4 gigahertz goes further,
Yes.
but isn't as fast.
That's
5
correct.
gigahertz doesn't go as far,
Yes.
and will be blocked by more things.
Yes.
But it's because it's a high frequency, we can put more data through it.
That's right. And look, that's common with all the wireless technologies. The higher the frequency, the faster of the data, the faster speed of the data you can get in there, or I should say the more data you can get in there. But yes, the lower the distance.
So as you get faster and faster and faster, you eventually get to light,
Yes.
right? So light can carry even more data, even faster. And that's why optical fiber is going to be way better than Wi-Fi, because we can carry more through it,
And
right?
that's right. And this is the same technology in, for example, a car radio.
Yep.
This is why you can have a car, you're picking up stations 50 kilometres away, because it's very low frequency. It goes a long way. It's only got to hold a little bit of data, because we know that voice doesn't actually consume a lot of data.
And why we need so many towers for 5G. But anyway,
Exactly.
moving past that.
Moving right along.
Right. So, let's talk about, and there's signals everywhere. And you go somewhere, there's a million Wi-Fi hotspots, there's people on the phone, there's radio stations, there's all sorts of things. How can I be signal free? How can I be somewhere with no signals at all?
Ooh, so you want like this little immersion tank of... okay.
Yeah.
So interestingly enough, there's a thing called a Faraday cage. And while it sounds sort of rather complex, it's really not. If I get a room and just put a wire mesh around it, now it could be like steel mesh, it could be chicken wire or something like that, that will actually block out radio signals.
When you ground it.
Sorry, very true. When you ground it, that's, I stand corrected.
Yeah, and depending on the size of the holes in the mesh,
Yes.
is the frequencies which are allowed in. So the smaller the holes, so that's why the front door of your microwave, which is actually a Faraday cage,
Yes.
has holes in it so you can see what's going on, and that won't let the microwaves out. In
Microwaves
fact,
out.
you can make the holes quite a lot bigger. Don't do this, by the way.
Don't try this at
Don't
home.
ever play with a microwave at all. They've got horrible things in them. They're really dangerous. Don't go taking one apart after this. But you can make the holes bigger safely to a degree if you know what you're doing.
Yes. And interestingly, again, some clients, when we've found why have they got Wi-Fi problems, they've actually mistakenly made a Faraday cage in where they've put the access point. Oh, we've stuck it in here, in between this router and this switch, in this metal cage with this metal door, in this room where the safe is, and we actually secured it and put bolts and metal things around it, and I'm surprised
then we
you can even get anything out of
drilled
it.
it to the floor and
That's
got
right.
nothing out of it. Yeah, I've seen enough Wi-Fi access points in
Yes.
metal cabinets. So
That,
that's,
by the way, that's also why access points generally have a plastic top.
oh, okay.
Good thing, if you've got a metal top and you're trying to pick up signal, the metal's going to block
Metal's
the
not
signal.
going to work.
Yes.
So, okay, so when I'm looking at Wi-Fi, I've heard not just the 2.4 and 5G, but I've heard things like 802.11a, B, C, etc. Now, I do remember 802. something from the really early days of my networking. I haven't done networking for a while, so I'm a bit lost now. But we were using those terms. Talk to me about those terms. Talk to me about the various naming conventions around Wi-Fi, so we can start to understand which one should I go by. Do I want to buy 802.11a, or is 802.11b/g better?
Okay, so let's have a look here. The 802 standards are a way to describe what we call a layer 2 transmission.
Mm-hmm.
And this is, I'm trying to get this very broad, and there are various standards and they change over time. So when we had Wi-Fi first coming out, we had 802.11b.
Yep.
That said, here is a 2.4 gigahertz signal. It can go a little bit of speed up to about 11.
It was 11
megabits per
megs,
second.
wasn't it?
Yeah,
Yep.
yeah, 11 megabits per second. And look, it worked. It worked, and you'd be competing against your microwave and anything else in the room. All those old wireless telephones, the deck telephones, they operate on that frequency.
Yep.
If you're in an apartment block, you've got issues aside from the concrete walls of things like who else has got a microwave, or who else has got a Wi-Fi, or who else has got... Yeah, so there's lots of issues. But that's your initial 802.11b, and that's from 1999, strangely enough.
Wow.
Yes.
Space 1999.
Yes.
I love that series.
Didn't notice Wi-Fi there, but anyway.
Well, no, they did, because they all had portable
of course,
tablets they
little
carried around
tablets.
that would have to communicate somehow.
The tricorder?
No, that's Star Trek. Let's not do this.
Okay. But the good thing about this is that being in that 2.4 gigahertz range, you could actually turn the power right up and send your signal a fair way, and it would work. But of course, the further away you got, the lower the speed in the end.
Yep. Cool.
Okay.
Got it.
Next part came 802.11a.
So A came after B at the same time as B and was faster. right?
Well, sort
Kinda
of,
same
yeah,
time,
sort
wasn't
of around the same time. But don't try to look at the alphabet as being resembling any time frame here. It sort of does, but it doesn't.
Okay, got it.
But A said, I'm going to do the same thing, but I know that the 2.4 gigahertz range is very flooded with all these other devices. Let's go and use the 5 gigahertz range.
And we could get up to 54 megs all of a sudden.
All of a sudden, you've got 54 meg. It's actually pretty clean because in most environments at that time, no one used the 5 gig range.
I remember my Windows XP Media Center wanted to have 802.11a to talk to my Xbox
And do you know why that was?
because 11 megs wasn't enough to run video-y stuff.
Possibly. There was another one that said, I know there's so much interference and so much competition for the 2.4 gig range that at least if I jump into here, I've got a fairly good chance of getting a really clean, crisp feed that's going to make me look good as a product.
Yep.
Okay. Look, something we should have mentioned, this 2.4 gig range and this 5 gig range, these are what we call public frequencies. They're unlicensed, which means they're available to use from anybody.
Okay, so we could go into spectrum licensing into a large degree. We might not go into that today. But governments around the world license various bits of the spectrum from the early days of radio and charge money for them. And there's certain areas, like, for example, the citizens band section, the cordless phone, 2.4G, and Wi-Fi, which are not licensed, so you can just use them.
They're not licensed. They're free for use from anyone. I used to have when cameras first came out in small form factor, like the little spy camera sort of thing. So there was one that was about 1 centimetre cubed. And I thought, oh, this is really cool. And it was like $10. And I thought, oh, I'm going to get one of these and try it out. The way it achieved its goal was if you turned it on, all of a sudden anything around it in the 2.4 gig spectrum just died. It used all the capacity it used, and it sent it out at such a high power level. I don't know how these devices got certified, but
perhaps they didn't get certified, and that was your fundamental issue.
I think that's the reality of it. Yeah, but it was actually good as a Wi-Fi jammer, even if it did send video pictures. So anyway, moving right along.
Let's move forward. We'll go forward 4 years to 2003. And that's when the ubiquitous 802.11g came out.
802.11g, yes. Now, I'm going to say one thing here. Wi-Fi, because of all these naming standards, .A, .B, .G, and so forth, in the early days when it was just technologists and engineers working on this stuff, that's fine. But now we're in sort of a Wi-Fi area where people don't really relate to these technical terms as much. Mm-hmm. So recently we've had marketing standards around, or the marketing people come out around the standards.
They've done some branding around the standard to make it more
they've actually been branded.
Accessible.
Now, you won't see Wi-Fi 1, Wi-Fi 2 or Wi-Fi 3 around, but 802.11b was Wi-Fi 1, 802.11a was Wi-Fi 2.
Cool.
802.11g that we're talking about is Wi-Fi 3. And yes, you can get up to 54 megabits per second.
Yep.
It actually is still in the 2.4 gigahertz range, and it worked out how to use that more efficiently and how to actually put more data into the streams.
Cool. So then in 2009, because that wasn't enough.
That's right.
600 megs Wi-Fi came out.
600 megabits per second, just what everyone needs on their laptop.
Routers with hundreds of aerials, because you can now have more than one.
That's
the
right.
more aerials, the better. I've been to Officeworks, right? And that was 802.11n.
That was when N came out, yes.
Wi-Fi 4.
Wi-Fi 4. And you even had some of these like fast N and N variants where they just turned the power up and did a few other little things. And not all of those were standards. Some of them were vendor specific. Oh, if we do this outside the standard, we'll boost it. So let's use that as our marketing differentiation. But it doesn't work with anything else.
Sure.
But anyway, so that was 600 meg, yes. 802.11n. That's Wi-Fi 4.
Wi-Fi 4.
And that is really where the marketing Wi-Fi's start. They'll start at a
so
Wi-Fi
we start
4.
at 4. Okay, so then 4 wasn't good enough because 600 megs, an eighth of a CD a second isn't really doing it for us.
That's right.
So we needed to get faster. So that was Wi-Fi 5, 802.11ac.
Yes.
Started in 2014 with wave 1 or wave 2. When did that happen?
So look, AC came out as the next generation passed in of all the Wi-Fi, and there were so many changes that they were working on. Like, it's a bit like when you're writing a bit of software. At what point do we actually release this?
Yep.
And they said, okay, look, let's put a stake in the ground here. This is wave 1. Actually, it was just called 802.11ac initially.
Yes.
Then it very quickly became, we're going to call this wave 1 because we've still got this backlog of all these changes we still want to get in there. And therefore, a couple of years later, wave 2 came out that had a lot of other features in it as well. But essentially, 802.11ac was the first point where you could get about 450 meg on the 2.4 gigahertz spectrum and about 1.3
gigabits per second.
Just what everybody needs.
So just be careful when we talk about bits per second. We're not talking about bytes per second.
No.
We're talking about, so if you're thinking I'm downloading a file that's 100 megabytes, or let's say 1 gigabyte, you'd think it would take less than a second, but it won't. It will take 8 times that because there's 8 bits in a byte. So you just need to be across that metric while we're explaining things. Cool. So 1.3 gigabits a second, right? On the 5 gigahertz.
The 5 gigahertz. Now, what's happening here is previously we'd have a person would connect to an access point, and let's just think about one connection. And the connection can go so fast and therefore hold so much data.
Yep.
And the closer you are, the better that connection is. The further away you are, the speed will slow down to compensate.
Because there's errors being introduced because you're going through a physical medium. Yep.
So with AC, actually, to be fair, with some of the older technologies as well, this is where we started to get into how can we make that connection better?
Yep.
How can we do things like either put more data on there, or how can we do multiple connections at once in order to give us more capacity?
Yep.
And this is where we start getting into some wonderful terms around things like multiple input streams, multiple output streams.
Yep.
You also get single user and multi-users, so you start to get these terms about SUMIMO and MUMIMO. You go, that sounds really great, but I've got no idea what it means.
Yeah, I've got no idea what that means, because I was still happy with my Wi-Fi 1. That was cool.
Yeah.
So before we get to the weird terms and we start to talk about orthogonal frequency division access,
Yes.
which luckily I read on the list, I've got no idea what that is.
Just what everyone needs to know.
Wi-Fi 6 came out in 2018. That's 10
Wi-Fi 6.
gigs a second.
It's a maximum of 10 gigs in theory, but yes, just in case your email transmission was not fast enough at 1.4 gig.
Yeah. Okay.
So there's some underlying issues here. Let's look at, there's actually a theoretical maximum of about 14 gigabits per second.
And that's all you can put through the frequency, right? You can't put any more.
There's only so much bandwidth, but what happens is you start to look at, and this is where SUMIMO and MUMIMO start to come in. Single user, multiple input streams, multiple output streams. My previous connection to an access point, here it is. It's like, think of it as a straw connecting you to your access point.
Yep.
Single user, multi-input, multi-output says, let me put 2 straws from this one person to the access point, and then let me put 4 straws, and all of a sudden you're multiplying.
But the access points can only have so many straws, right?
That's right, and this is why you start to get multiple antenna
right
on your.
But they still can only have so many straws.
They can.
So you can't just wander into an area, let's say a busy office area or a stadium or a bar, and put in one access point and go, she'll be right, mate.
People have tried, and they've generated an interesting result of.
Yeah.
Yes.
You'd know that if you ever try free pub Wi-Fi. You know exactly how that works.
It's good when there's no one here.
Yeah.
Yes. Look, so we went from single user, multi-in, multi-out, to multiple user, multi-in, multi-out, as in multiple end users being able to do this multiple channels or streams at the same time.
Yep.
And this is where AX comes from. 802.11ax starts to allow multiple people running multiple channels or streams at the same time to send faster amounts of data over shorter distances. So this is where you can get up to, in theory, 3.5 gigabits per second of capacity times 4 channels at once.
Wow.
Giving you 14 gigabits per second. So imagine you've got email coming in at 14 gigabits per second now instead of.
Sometimes it feels like I get emails at 14 gigabits a second, Scott.
It does. But there's an underlying issue here. And it's actually quite a simple issue. And this is why you'll find stuff doesn't work in the stadiums. And stuff doesn't work at home when you try this.
Well, because I'm starting to hit other bottlenecks, right? So,
you are.
So it's all very well and good having Wi-Fi a bottleneck, but what am I connecting that access point to?
Well, this is it. So think about a road outside your house, and every morning you drive out. Well, it used to be every morning. you drive out, and you get in this queue of traffic because the road's only 2 lanes long.
Yep.
And eventually you hit a freeway. It's got 8 lines, and you sort of say, "Oh, that's great! Look," and everything flows really quickly. Think about that 2-lane road. Okay, and someone comes along and says, "Oh, we need to make this bigger. We've now got 4 lanes here or 8 lanes here."
So I've turned it to gigabit Ethernet, but you're still telling me more's coming out of my access point than I've fed into it. So I'm still limited down to a gig, right?
It just moves the problem somewhere else.
Yeah.
So.
And then when do I get the point where my device actually can't cope with that kind of data stream, right?
Well, there is.
Right, I've got a 3 gigahertz processor. Let's say I've got a top of the line 3 gigahertz processor. It can only do 3 billion instructions per second.
Moore's law.
It can't process more data than is coming from my Wi-Fi access point now.
This is actually an interesting discussion in itself, but it used to be that when we had gigabit network interfaces coming out for servers.
Yep.
And also workstations. Workstations, the chipsets in them were only at the point of reaching about 300 megabits per second. Yeah. Now, you would have to have a gig interface because it's more than 100 meg. but you couldn't actually get more than about 300 meg until, over time, the next generation of chipsets came out and the next generation of servers came out. Servers got up to about 800.
I remember sitting down with people and they say, I've just put a 1 gig Ethernet card and it's not going any faster. I went, well, your bus speed is 300 megs, right?
That's right.
You can't put a football down a garden hose. It ain't going to work.
And you previously had 4 1 gig links or 4 100 meg links or whatever it was. Yeah, that's right. This is where people plug their access point in via an Ethernet cable into their switch.
Yeah.
That's a 1 gig link.
Yeah, but what's the speed of the backplane of the switch, you know? And what about the core router?
The switch is not an issue. Actually, switches these days, modern switches, will actually operate at line rate capacity.
Okay.
Even like the $200 odd switch you can get from the corner store.
So don't worry about switches.
Don't worry about your switches.
Bottlenecks everywhere in this.
There are
environment.
bottlenecks. But
then you go out to the NBN and it all goes...
It's exactly the same issue. It's not always about individual components. It's about the sum of them all together and making sure they all work.
Yep.
We talk about looking at Wi-Fi in a stadium. So think about it. There's one access point. All of a sudden, you've got 500 people trying to connect to it.
Yep.
And you've got one cable at 1 gigabit per second trying to do all the backhaul. Meanwhile, everyone's trying to download all this stuff at a few meg per second. You just haven't got that much capacity.
Yes.
Now, this is why access points, the higher end ones, have now got 2 network ports on them to put 2 cables in for 2 gig. And the even higher end ones at the enterprise and stadium level actually have ports that can run at, HP does a thing called a smart rate, 2.5 gigabits per second and now 5 gigabits per second.
Wow.
And now there's access points coming out with 10 gigabit per second interfaces.
Yep.
But you've got to have the cabling or the fibre.
And
to
the
actually support it.
infrastructure, and you've got to have the switching, and you've got to have the...
It's end-to-end.
And you need an internet connection slightly larger than...
So you'd think if we put all these access points in a stadium, let's say we give every single person that goes into one of those big stadiums of 80,000 odd people or whatever it is, their own access point to connect to. And they've got 1.4 gigabits per second back there, but the stadium has a single 100 meg NBN.
It's all over.
link.
It's all over.
Yes.
But then it gets worse because the stadium's only used when there's games.
That's
so
right.
you have all this amazing capacity for 2 hours a week.
Yes.
Which is... Yeah, you start to get crazy.
The
with those
Wi-Fi
things.
is like professional services. You can't do it and put it on the shelf.
Yeah.
You can't transmit it the day later and then find out, what is it? It's a voice call. Well, I needed it the day before when I was trying to talk to someone, not the next day.
Good point. All right. Okay. So that's backhaul. That's stadiums. We talked about that. There's some other flavours. We'll just skirt on these. They're just around the periphery. Okay. So 802.11r.
So the 802.11 standards, there's a whole list of them, not just the ones around the specific Wi-Fi 1 to 6, but there's all these different variations that deal with a lot of things. There's an R that deals with fast roaming. Fast roaming is when I'm connected to access point A in a business, for example, and I'm on a phone connecting or I'm on a laptop and I go for a walk and I start to get out of range of that access point, such that because I'm further away, my speed drops below a certain point or I lose connectivity with it. But then, if this is designed properly, there's a second access point where you're heading that's going to pick up your
signal. And it
signal.
picks you up and you roam quickly to the second access point.
There's a difference between normal roaming, which can take a few seconds to cut over.
Which you don't want to do in a voice call.
And if you've got an active voice call on, you want fast roaming, which actually means that access point A is continually telling access point B that I know about these people, they're here, and if you start to pick up a stronger signal than I do, just go for it. Don't drop the call.
Right. So, interestingly enough, and I'm not going to talk about the management interfaces, there's loads. We'll move past that.
Okay.
Bluetooth is also a kind of form of Wi-Fi.
Yes, well, it's a 2.4 gigahertz signal. It's a low-powered one.
And it does 1 to 3 megs a second.
Yes.
Megabits per
and
second.
even the new BLE, Bluetooth Low Energy ones.
Yep.
They're very short range, just a few megabits per second at most. They're really designed for things like in hospitals, put asset tracking tags on beds, on machinery, and knowing that it goes blip and you know that bit of machinery you're after happens to be on level 4 in this room.
Cool.
Yeah.
So, Scott, it looks like we've covered most of Wi-Fi.
Yes.
We've covered what it is, how it works, backhaul considerations.
Yes.
Wi-Fi security.
Oh, look, security is a whole area in itself. There are so many issues around Wi-Fi security, and when we actually talk a bit about them, you'll realise, oh, well, that actually could be happening to me. And it's just not a popular topic, but it's a very important topic, such that we're going to cover an entire podcast on Wi-Fi security issues.
Excellent. I look forward to that. Let's do that.
So do I. I'll see if I can hack into your Wi-Fi in the meantime.
Sounds good. So, if you want to hear more about Wi-Fi and security, please click on the link below, probably over there by Scott, and subscribe to our podcast. Also, join us on Facebook, listen to us on Spotify, on iTunes, or wherever you get decent podcasts. I hope you've enjoyed the session. I have to say thank you to Scott. Thank you, Scott.
Thank you, Nick, and thank you, everyone. Happy Wi-Fiing.
And I hope you have a super day. Thanks for listening. See ya.
Bye.